Last section in chapter 9 where we're learning how to change objects location, rotate, reflect. The last thing we have to do is change the size. So when we dilate something or change the size of it, either make it bigger or smaller, the angles stay the same and the sides are proportional. So we're going to be talking about something called scale factor, which is what we are going to use to change the size of something. What do you think will happen if we have a scale factor of 1? Yes. So what happens if the scale factor is bigger than 1? What happens to the shape? It gets bigger. What happens if the number is less than 1? It gets smaller. Okay. So 1 is kind of that break-even point. So let's take a look at this first one. If I ask you to find the scale factor, which I'm going to ask you to do that on the homework coming up. First of all, notice that we've got numbers on 2 of the sides that are related to each other, okay, the longest side of the triangle. So the scale factor is either going to be 6 over 18 or 18 over 6. Let's talk about, did this triangle get bigger or did it get smaller? How do you know that? The primes tell you that this is what the picture ended up as. So this blue triangle was the ending picture. So it got smaller. So which one, well, before we do that, let's simplify these. This would be the same as 1/3 or 3. Which one would be the scale factor for this picture? 1/3, because it got smaller. It didn't get 3 times bigger. It got 1/3 the size. Okay, so that's how you're going to answer those questions when they ask for the scale factor. There are 2 types of dilations. We've already talked about both of them, getting bigger and getting smaller. So most people see the word dilate and they think it means just getting bigger, but it can also mean to have a reduction or be reduced in geometry. Okay? Questions on scale factor? All right, so there are going to be pictures like this in the homework. These are overlapping pictures. You could think of them as ice cream cones. So what I'm going to do is I'm going to draw them separately. So here's one, and here's the bigger one. Then we're going to label these. Okay, so on this little ice cream cone, what numbers will I put on it? This is 5 and this is 4. What's going to go here? And what goes here? Why do you think I had you draw them separately? What do you think is a very common mistake? What number do you think kids use? 3. Okay. 3 is just the difference in how long those ice cream cones actually are. So when we're going to solve for x in a situation like this, we're going to set up a proportion. Okay. As long as we set up the second fraction the same as we set up the first fraction, we're good to go. So what could we compare to one another? We could compare 5 to 8. We would have to go in what order then? 4 to x. Okay. We could also compare 5 to 4 as long as we set up the second one as what? 8 to x. You have to go in the same order. When you cross multiply, you're going to get the same answer on both of them. Okay. So when we do cross multiply, what do we have here? And then we divide by 5. We get 6.4. So there may be a situation on your homework where you need to cross multiply. Not all of them are that way, but that's how you would set those up. Questions? What is the scale factor on this one? What numbers would we put together for that? We could do that. It would be a little bit cleaner to use what numbers? Maybe 5 and 8. Okay, because they're on the same location. just like we had with the two triangles on the last page? Would it be 5/8 or would it be 8/5? Why? It got bigger, B to B prime, so that was getting bigger, the ice cream cone got 8/5 bigger.
Wait, wouldn't it be the other way around?
Question? When these numbers, the 8 and the 5? Do you mean the 8 and the 5 be the other way around? Okay. Because it's getting bigger, we need to have our scale factor be bigger than 1. And 8/5 is bigger than 1. 5/8 is smaller than 1. Okay, so we got bigger, our scale factor needs to be bigger. Questions? Okay, so we are going to be doing this most of the time on a coordinate graph, which is actually really easy. So let's say we had a triangle like this. We're not going to graph this one, we'll graph the one on the next page. Let's say we had these coordinates for the triangle and we wanted to make it 4 times bigger, scale factor of 4. Okay, here's how we're going to do that in the margin of our paper on the graph. First, we're going to put the coordinates that we need to make 4 times bigger. So we're going to take these and put them in a matrix. Now, do we have to move one matrix C up and then pair things together and multiply them and add them together when we're doing this process? No. When do we do that? When would we do all that work? Yeah, when we take one matrix times another matrix. We're not doing that here. We're taking a matrix times a single number. So what do? Yeah, everything just gets times by 4. So then you would graph these points, and that triangle would be exactly 4 times bigger. So we're going to practice that right now on the next page. Okay, this is going to be very similar to a test question that you're going to see in a couple of days. Okay, so we're going to start with this. We're going to do both of these. We're going to start by rotating 90 degrees, since we need a little bit of review with that. And then we're going to dilate it by 1/2. All right, so looking at this one, what are we going to do first if we have to rotate 90 degrees? We're going to actually turn your graph 90 degrees counterclockwise. So now it looks like this. What should I see in the margin at this point? The new coordinates. Okay, so let's label this. Let's put an A on that one, a B on the axis, and a C here. Okay, so we're going to go A prime, B prime, C prime over here. Where is A now located? B is now at Is it that way or this way? Okay. What about C? -1. Okay. Now we have to turn it back the way it was facing. Hold on. And we're going to plot those points over there. So now we're going to go, here's B prime, A prime, and C prime. Okay, so we did the first transformation. Now we need to dilate this red triangle by 1/2. So what are we going to do for our work off to the side? We need to first write it as a matrix. I'm going to be looking for this in order to get all the credit. You need to be showing this work. So the new coordinate right here, We have them right here, right? This is where they currently are sitting, the red one. So we can put those here. And we're going to multiply this by what? 1/2. This will equal our final location right here. So all of these get cut in half. So we're going to take all of those coordinates. Here's A double prime, B double prime, and C double prime. So we have the exact same triangle, it's just half the size. Questions? Yes, no?